So far in this unit, we have talked about, I should say this year, so far we've talked about different kinds of functions. So we've talked about linear functions where it's a y equals mx plus b form. We've talked about quadratic functions this chapter where it's y equals ax squared plus bx plus c. We've talked last chapter about exponential functions where it's y equals abx. So we're going to talk about in this lesson how to tell what model they're using and how to determine the equation. So the first group of questions just says to graph each set of ordered pairs, determine if it's linear, quadratic, or exponential. When we graph these, all we have to do is look at the shape. The shape will tell us what kind of function it is. So number 1, negative 2, 5, negative 1, 2, 0, 1. Sorry about that. Maybe this worked better. 0, 1, 1, 2, and 2, 5. So we know that this shape here is a quadratic because it gives us a parabola. The next one, negative 2, negative 3, negative 1, negative 1, 0, 1, and 1, 3. We know this is a linear function because it's a straight line. And the last one, 0, 1, 1, 4, 2, 16 would be way out of the screen. And we know that this is an exponential function. So we can use a set of ordered pairs to determine what kind of function it is. The next group of questions, look for a pattern in each table to determine what model is used from a table instead of a graph. So the first thing we're going to do is look for a pattern in the y values. So this is plus 5, plus 5, plus 5, plus 5. And up top it goes up by 1 each time. So we know that if it is a constant value or constant ratio in the y's, that it's linear, because our slope would be constant. The change in y over the change in x is constant here, which means it's a linear function, straight line. We do the same thing here. Minus 4, minus 2, minus 1, minus 0.5. That's not a constant function. So then what we do is we look at the difference between those values. That's plus 2, plus 1, plus 0.5. And that doesn't tell us anything either. So this is an exponential function. If it was a quadratic function, these right here, these values would all be the same. So if you look here, this is multiplying each time by 1/2. 8 times a half is 4. 4 times a half is 2. 2 times a half is 1. 1 times 1/2 is 0.5. So that's an exponential function. In number 6, this is going down by negative 4, the first one, then negative 2, then 0, then positive 2. So that's not a linear function, but we look at the difference between these values here, plus 2, plus 2, plus 2. Now we have a constant change. So this is a quadratic function. That's how you tell it's quadratic. If not the first values of x, but the second common difference is the same, then that tells us it's a quadratic function. So we can tell what kind of function it is by a picture, we can tell by table values. And now on the next page, we're going to come up with the equation. Sorry about that, I didn't mean to move that. We're going to come up with the equation. So I need to determine first what it is. So minus 14, or minus 10, sorry. This is minus 6, this is minus 2. Then I'm going to look at these. So this is plus 4, plus 4, plus 4. So now I know that the second row of differences are the same. So this is a quadratic. And a quadratic has the general form of y equals a times x squared. So I found, I know from the table that it's quadratic because I got 4 for all these. So I'm going to pick a value out of this table, x and y. I'm going to plug it into y equals ax squared. And that's going to leave me with one variable to solve for, which is a. So I'm going to use -1 and 2. Y is 2, and x at that point is -1. So now I can solve for a and figure out exactly what that coefficient is. So -1 squared is 1, so I have 2 equals a. So I plug it into y equals ax squared, and I get y equals 2x squared is my equation that's represented from the table. Number 5, I'm going to figure out if there is a constant ratio. And as you go across here, you'll notice that there is a constant ratio of -4, and the values on top are 1. So that means this is a linear equation. And linear equations are written y equals mx plus b, where m is the slope and b is the y-intercept. So I know that m is -4, that's the slope. And I know b is the y-intercept, so when x is 0, that's where it crosses the y-axis. In this table, it tells me right here that y is 3 when x is 0. So my equation for this one would be y equals -4x plus 3. Number 6, if you look at the y values going across, there is no common difference, so I need to figure out what's happening from each one. The decimals might not seem so obvious, but when I look over here, 1.5 to 3, that's times 2, and it works for 3 to 6 also. And if I go backwards, that's true. So the general form for an exponential function, which this is y equals abx. B happens to be the common difference. So B is times 2. I know what B is. So I'm going to plug in B in for here. A, I don't know what it is. And now I'm left with x and y, which I can get from the table over here. So I'm going to use 3 and 0, because that's kind of an easy ordered pair to use. X is 0, and y is 3. So I have y equals a. Oh, sorry, y is 3, I said. So my point is 0, 3. 3 equals a. 2 to the 0 is 1. So a equals 3. So now I know what a and b are, so I can write the equation y equals a is 3 times b to the x. So y equals 3 to the 2x would be my equation. So I use the general form, plug in the pieces that I can figure out, and write the equation like that. Number 7, the table shows the cost of placing an ad in a newspaper to determine the model. So I'm going to figure out what the difference is. This is plus 210, plus 210, plus 210. So this tells me it's a linear function, which is y equals mx plus b. I check to see if the x values are continuous, and they are. So I know that my slope is 210. So m is 210. I don't know what b is right now, but I can find b. I'm going to pick a value from the table, x and y, plug it into here, and that's going to leave me with one variable to solve for, which is b. So x is 5 newspapers, y is 1450. So I solve this. 1450 equals 1050 plus b. Subtract 1050 on both sides. I get 4 equals b. So now I can write the equation y equals my slope 210x plus 4 is my equation that represents that data. As always, if you have any questions, feel free to ask.